As our nebula began to collapse under its own gravity and spin faster, a dense clump of matter formed in the center. It's called a protostar. At first, its heat was due to friction, but when the clump reached 18 million degrees Fahrenheit, nuclear fusion kicked in. 4.5 billion years ago, our star was born. Hydrogen atoms fuse together to form helium, and in the process, release photons. It's the first light made by our sun, and it will keep on shining for 4 billion years. A vast nuclear furnace nearly 1 million miles across. From a distance, this process seems almost peaceful, with the sun's power gently radiating out into the early solar system.
There was all sorts of activity going on. Things were changing rapidly, violence, explosions, intense radiation. We had a pretty spectacular origin, I think.
Recent research suggests the solar system's birth was far from peaceful. Our sun may in fact have been born out of one of the most violent events in the cosmos: the explosive death of another star. And even before that, it seems there was an explosion so huge that it created an entire universe. The Big Bang. No one knows what caused it, but we think that the Bang created space, time, and all the matter in the universe. Yet for astrophysicists, such as Professor Stan Woosley, there's a puzzle. The Big Bang produced almost none of the 88 naturally occurring chemical elements.
When we look around, we don't just see hydrogen and helium. We see planets and people, and we're made out of carbon and oxygen, and planets are made out of iron and silicon. And that didn't all come from the Big Bang. It had to come from somewhere else.
Here on Earth, we have learned how to create new elements for ourselves. Nuclear technology. The same thing happens inside stars. Hydrogen and helium from the Big Bang fuse to form heavier elements. And if the star is big enough, at the end of its life, it does something spectacular. It explodes.
The energy of a supernova explosion is essentially equal to all of the energy that the sun will put out in its 10 billion year lifetime.